Hello, this is Adam. I'm going to do mechanics of 2 kg block and then 5 kg block and then inextensible string, a rough horizontal surface that has friction on it. Okay, and then we have force F and we have angle of 20 degrees, and we're required to state Newton's second law. So Newton's second law can be stated as the rate of change, so that's the rate of change in momentum actually. So that's the rate of change in momentum, right? So that's it. We have other expression like force direct proportional to acceleration and so on, but that's the shortest one. So draw free body diagram. So free body diagram, we have 5 marks, so which means 5 forces. So your forces should be 5 or more. So that's 5 kg, that's our point there. And then we have force applied, we have weight, we have normal force, we have tension and friction, and then that's it. So from the sketch there, we draw a free body diagram. That's the force applied, that's F. And then we have weight there, we have normal force, okay, that's normal force, and then we have tension, and we also have friction there, and that's weight. So that's 1, 2, 3, 4 and 5 forces for the 5 marks. And then move on to this last question. It says we should find the force F at that angle, acceleration given as 2 meters per second squared. So let's get the data statistics. What we have, we know that we have mass 1, which is 2 kg, and we have let me just get a calculator. We have mass 2, which is 5 kg, and then we have angle of inclination, which is 20 degrees. What else do we have? We have rough surface. So rough surface, that means that we have friction, so friction will be considered. We have friction 1, which is 10 Newton for the 2 kg, friction 2, which is 15 Newton, which is for the 5 kg block. And let's deal block by block and apply Newton's second law on each. Block 2 kg, let's get information for that. So block 2 kg, we have T, tension that we don't know, acceleration we think we don't know, but we're given, I think. And then we have friction for 2 kg is 10 Newton. Acceleration is 2 meter per second, so 2 meter per second squared. And then let's get another data for block 5 kg. So we're going to apply Newton's law on both. So we start with one and then we do it with the other. So we have let's see what we have. We have force at an angle, force at 20 degrees, so which means our theta there is going to be 20 degrees. And then we have tension, which is we don't know. And then we have acceleration, which is 2 meter per second squared. And then we have friction there, which is 15 Newton. And then we have that for 5 kg. And then what else? We're done. Now let's apply Newton's second law on block 5 kg first. So block 5 kg, we have force net is equals to ma, and then we have Newton, that's Newton's second law. So force net, let's go and identify what our force net is. we have force applied, friction and tension. So friction and tension are in the same direction against force applied. So these are 3 horizontal forces. So 3 horizontal forces going to that direction, and then we have the friction there, we have tension, and then force applied, friction, tension. That's the horizontal. Nothing is moving on the vertical part. So what we have now is force net is equals to force multiplied by cos 20 degrees minus, because the friction is in opposite direction, friction minus tension is equals to MA. Alright, so we know that force F we don't know. That's gonna be cos 20 degrees for horizontal direction, and then we have for friction there is 15 Newton for the 5 kg, and then tension minus tension is equals to mass is 5 kg. So you put 5 kg there, and we have acceleration, which is 2. Okay, so immediately when we do that, we simplify. So we don't know the force, is still gonna be force cos 20 degrees, and we don't know okay, 15 minus t is equals to 10, and then we know that, okay, we take the 15 there to the right, so it's cos 20 degrees. We take 15 to the right, it's minus t, it's going to be 15 to the right is going to be positive, so that cancels out, so that's going to be 25. So that means now we have 25, and from there that will be our equation 1. Okay, so once you complete the Newton's second law on one block, it becomes equation 1 in a simplified version. Okay, so simplified. So now we do block 2 kg, we do the same thing. So block 2 kg, we can go back and see what we can have. So we have force net once again is equal to MA, and we know that force net, let's go look at the problem. We have weight there, we have normal force, and then we have there's tension, and then we have friction. So what that's Newton's second law, and then what we do now, we apply it. So you see the horizontal forces, we have tension there, that is friction for block 2, and tension is the same as the other block. So T minus friction is equals to MA. Remember, friction was positive there, I mean tension. Now tension here is, the tension was negative, but here is positive. So block 2, we have friction there as 10. So our friction there is 10, our mass is 2, and our acceleration is actually 2. So we have tension minus T is equals to 4. Now T is going to be 10, move to the right, it's going to be positive, so 4 plus 10 is going to be 14. So T is 14, and that becomes our equation 2. Okay, so from equation 2, what we now have is that we conclude all the facts that we have. So we're gonna write first equation, F cos 20 degrees minus T is equals to 25. So that's from our equation 1, and then we have that one there, which is positive T is equals to 14, and then that's our equation 2. So with that in mind, we add everything. So remember, when we add, the tension cancels out, so we have 0T there. Yeah, that's 0T is equals 5 plus 4 is 9, so 2 plus 1 is 3, so we have 39, and then plus F cos 20 degrees, and then from there we know that force cos 20 degrees is going to be 0T 0, so it's 39, and then we divide both sides by cos 20 degrees. So when you divide both sides by cos 20 degrees, and then we find our answer, that is the cos 20 cancels out on the left, so it reappears on the right, the bottom. So that means now we have force F is equals to 39 degrees divided by cos 20 degrees. Now from there, what we have, we use a calculator. So there's a calculator there, so you can see 39 divided by cos 20 degrees. It gives us 41.50. So that's our final answer. We're done. We calculated F. So you can redo the question once again, and I appreciate. And this is your tutor, Black Adam, and don't forget to follow or subscribe. So that's our final answer there, and you can follow the steps. I hope you understood everything. And as usual, I'll say if you like the channel, you can go on and search for similar topics on tension, and then just browse through the videos, you'll find them. But I'll keep developing more. So this is your tutor, Black Adam, and I really appreciate your company and your time for watching. I hope you're helped. Any comments, please leave below. Thank you so much for watching.